Welcome back again, dear students. We know that the definition of DFT. So if x of n is a continuous time signal functions, then the DFT of x of n is given by x of k is equal to sigma n is equal to 0 to n minus 1 x of n into wn nk, where k can have any values between 0 to n minus 1. That is 0 less than or equal to k less than or equal to n minus 1. K can either be 0 sample, first sample, third sample, etc. up to n minus 1 sample. That is, k has n number of samples. Now let us represent what is wn. So representation of samples. How we represent the samples? Let us consider wn. Wn means it is given by exponential minus j 2 pi by n. Here wn represents the samples, where n represents the DFT point. For 4-point DFT, we represent it is W4. WNK. K can represent the number of samples. Since Wn equals exponential minus j 2 pi by n, Wn to the power of k is equal to exponential minus j 2 pi by n into k. And therefore W4k is equal to exponential minus j 2 pi by 4 into k. It is equal to exponential minus j 2 pi by 4. 2 by 4 is pi. 2 pi by 2k. Therefore, in general, we can represent the 4th point DFT as W4k is equal to exponential minus j pi by 2k. This has 4 samples. All the 4 samples are W40, W41, W42 and W43. So k has 4 samples, 0, 1, 2, 3. Therefore k can be written as 0 less than or equal to k less than or equal to n minus 1. Here n is 4. That is 4 minus 1. Or 0 less than or equal to k less than or equal to 3. 0, 1, 2, 3. So k has 4 values. So W401 is 1 sample. W41 is the second sample of the 4-point DFT. W42 is the third sample of the 4th point DFT. W43 is the 4th samples of the 4-point DFT. And these are represented on a circle of unit radius. Consider a circle where the radius is unit. The radius is unit, r is equal to 1. Since this is the radius, this is the 1. This is positive x-axis. This is negative x-axis. Therefore, this is minus 1. This is y-axis, an imaginary axis. So, therefore, this is plus j. This is minus j. And we know that all the samples are spaced equally. The entire angle is 360 degree. There are 4 samples. 360 by 4 is 90 degree. If each samples are placed at 90 degree. This is the 0 sample represented by W4 power 0. You know that W4 power 0 is equal to 1. Anything to the power of 0 is 1. This is the first sample. Second sample is at 90 degree. This is W41. W41 is equal to plus j. This is the next sample. This is W42. Third, 0, first, second. First sample, second sample, third sample of 4-point. That is W minus 1. Next, W43. W43 is the first, second, third, fourth samples, which is given by minus j. Therefore, we represent W4 is equal to 1. W41 second sample is plus j. W42 is minus 1 and W43 is equal to minus j. These are the 4 samples. How do you calculate these samples? Let us calculate the number of samples, the value of the given samples. Now, let us calculate some DFT samples. First, let us calculate for n is equal to 4-point DFT. The samples are represented by WNK, which is equal to W4K, which is equal to W4 means exponential minus j 2 pi by 4 into k, which is equal to exponential minus j 2 pi by 4 is pi by 2 into k. Since n is equal to 4, k can have 4 samples, 0, k equals 0, 1, 2, 3. That is 0 less than or equal to k less than or equal to 4 minus 1. 0 less than or equal to k less than or equal to 3. 0, 1, 2, 3. There are 4 samples. Let us calculate each sample. We know that exponential minus j theta is equal to cos theta minus j sin theta. Exponential e power minus j theta is equal to cos theta minus j sin theta. And W4 is equal to exponential minus j pi by 2. Therefore, it is equal to cos of pi by 2 minus j sin of pi by 2. E power minus j theta is cos theta minus j sin theta. And W4k is equal to exponential minus j pi by 2 into k, which is equal to cos of pi by 2k minus j sin of pi by 2 into k. The first sample is k equals 0. So k equals 0 is the first sample. Therefore, that is W4 to the power of 0 is equal to cos of pi by 2 into k. K is 0. That is cos 0 minus j sin of k is 0 sin 0. Cos 0 is 1 minus j into sin 0 is 0, which is equal to 1. So W40 is equal to 1. That is the first sample. The second sample is W41, which is equal to cos of pi by 2 k is 1 minus j sin of pi by 2 k is 1. Cos pi by 2 is 0 minus j into sin pi by 2 sin 90 is 1, which is equal to minus j. So minus j is the second sample of 4-point DFT. 1 is the first sample of 4-point DFT. Next sample W42 k equals 2. That is cos of pi by 2 into 2. K is 2 minus j sin of pi by 2 into k is 2. So that is 2 to get cancelled. Cos pi. What is cos pi? Cos pi is minus 1. Minus j into 2 to cancel. Sin pi. Sin pi is 0. It is equal to minus 1. So this is the third sample of 4-point DFT. Again W43, the last DFT point. Fourth DFT point is cos of pi by 2 into k is 3 minus j sin of pi by 4 into k is 3. Cos 3 pi by 2 cos 3 pi by 2 is 0 minus cos 3 pi by 2 is 270, that is 0 minus j into sin pi by 4 into 3 pi by 4. Sin 3 pi by 4 is 1, which is equal to minus j. Therefore, 4 samples of 4-point DFT is W4 equals 0 is 1, W41 is equal to minus j, and W42 is equal to minus 1, W43 equals minus j. And you can represent these 4-point DFT in a unit circle of unit radius. All samples must be equally spaced. This is a circle of unit radius, and the samples are representing the anti-clockwise direction. Therefore, this the first one is W4 power 0, which is equal to 1. Another sample is W41, which is equal to plus j. This is W42, which is equal to minus 1. And this is W43, which is equal to minus j. This is plus 1, this is minus 1, this is imaginary axis plus j, this is negative imaginary axis minus j. W40 is 1, W41 is plus j, W42 is minus 1, W43 is minus j. These are the 4 samples. Similarly, now let us calculate some other samples. Examples. Let us calculate W82. How do you calculate W82? We know that Wn is nothing but exponential minus j 2 pi by n. Similarly, W8 is nothing but exponential minus j 2 pi by 8. Instead of n, you have 8, which is equal to exponential minus j pi by 4. 2 fourthly, so pi by 4. So W8k is equal to exponential minus j pi by 4 into k. Now here k is equal to 2. W8k, here W82 you have to find out. That is, instead of k, it is 2. Therefore, W82 is equal to exponential minus j pi by 4 into k is nothing but 2, which is equal to exponential minus j cancels pi by 2. That is equal to cos of pi by 2 minus j sin pi by 2, because e power minus j theta is cos theta minus j sin theta. Cos pi by 2, cos 90 is 0 minus j sin pi by 2, sin 90 is 1, which is equal to minus j. Now let us calculate W83. W83 can be written as e to the power of minus j. W8 is e power minus j 2 pi by 8 into k is 3. It is equal to exponential minus j 3 pi by 4. By definition, e power minus j theta is cos theta, that is cos 3 pi by 4, minus j into sin theta, that is sin 3 pi by 4. What is 3 pi by 4? Cos 3 pi by 4 is 1 by root 2, minus j into sin 3 pi by 2 is also 1 by root 2. How do you calculate cos 3 pi by 4? Cos of 3 pi by 4, which is equal to cos of 3 into pi is nothing but 180 divided by 4, which is equal to cos of 4 4 4 4 25 3 5 15 5 ಅಷ್ಟು 1 4 12 cos 135. So cos 3 pi by 4 is cos 135. Cos 135 can be written as cos of 180 minus 45. Cos 180 minus 45 is cos 135. Here cos 180 is even multiple. Therefore cos becomes cos itself. It is in second quadrant. Since it is in second quadrant, AS sin and is reciprocal is positive. But cos is negative. Therefore it is minus. That is cos 45. So minus cos 45 is 1 by root 2. Therefore cos of 135, 3 pi by 4 is minus cos 35, this is minus 1 by 2. Therefore here it is minus 1 by root 2 minus j into 1 by root 2. So cos 3 pi by 4 is minus 1 by root 2 minus j sin 3 by. Similarly sin 3 pi by 4 is sin 135. Sin 135 is sin 180 minus sin 135. Sin 135 is sin of 180 minus 45. Sin 135 is equal to sin of 180 minus 45. Here sin 180 is even multiple, therefore sin becomes sin. Second quadrant sin is positive, therefore plus. This is equal to plus 1 by root 2. Therefore W83 is equal to minus 1 by root 2 minus j 1 by root 2. Similarly, you can calculate any value or any samples of given endpoint DFT. Now let us calculate another sample example. Let us calculate W84. We know that W8 is exponential minus j 2 pi by 8. Here k value is 4 into 4. Knock only, knock early. 2 to get cancelled. E to the power of minus j pi. So e to the power of minus theta is cos of pi minus j sin of pi. Cos pi is minus 1. Minus j sin pi is 0, which is equal to minus 1. Therefore W84 is equal to minus 1. In this way you can calculate any values of W. So W values can be calculated using the formula Wnk is equal to exponential minus j 2 pi by n into k, and also which is equal to cos of 2 pi by n into k minus j sin of 2 pi by n into k. Using this formula, you can calculate any value of Wn and k. Thank you.